Fact number 1. For any integer, which we're calling n squared is the sum of the first absolute value of n odd numbers. For example, the pattern starts at 0, and 0 is the sum of 0 numbers. It's the empty sum. After that is 1, which is 1. After that is 4, which is 1 plus 3. And after that is 9, which is 1 plus 3 plus 5. Do you see the pattern? After that we add 7 to get the next perfect square, which is 16. And then 9 to get 25. And then 11 to get 36, and so on and so on. Fun fact number 2. A power set number, with the exception of 1, is the only type of number with no odd number as a factor. This is because their factorizations would build out to be a product of all 2's, and 2 is by default the only even prime number. Speaking of power set numbers, the third fact is about them too. If you take all the proper factors of a power set number and add them all up, which is referred to by mathematicians as an aliquot sum, it will equal exactly 1 less than the number itself. This is why power set numbers are often referred to as almost perfect numbers. For any perfect power with base b and exponent n, b to the power of n minus 1, all divided by the group b minus 1, will always equal an integer, no matter what b or n is. Fun fact, 77 is the first composite number to not achieve any of the following: be even, have a last digit of 5, have a digital sum divisible by 3, or be a perfect square. Coincidentally, it's also, surprisingly enough, the first whole number to have 5 syllables in its English pronunciation. Speaking of the first in groups of composites, 121 is the first composite number to not have any one-digit prime as a factor. It's not divisible by 2, 3, 5, or 7. The 12th prime number is 37. If we switch the order of both numbers in that statement, we get the 21st prime number is 73, which is also true. Coincidentally, 21 is also the digital product of 73. Multiplying both 37 and 73's digits will equal 21. For any integer n, 6 times n plus or minus 1, all squared, is congruent to 1 mod 24. No matter what number under that criteria is squared, as long as it's a whole number, of course, dividing that number by 24 will always leave a remainder of 1. With the exception of 15, any product between two twin primes, meaning two primes that are exactly 2 apart, will always be congruent to 8 mod 9, whether it's 5 times 7 or 11 times 13, or 17 times 19. Dividing it by 9 will give 8 as a remainder. Have you ever looked at a number and wondered if it's prime? If so, the Pascal triangle is here to help. Why? Because, bearing the two overarching ones on every Pascal triangle line, if a number is prime, its designated line in the Pascal triangle will only consist of numbers that are multiples of said number, which isn't the case for composite numbers. For example, 7's Pascal triangle line consists of 7, of course, 21, and 35, all of which are famously divisible by 7.